Hello and very welcome this UN Day, the 24th of October at the World Heritage Grimeton radio station, Sweden. We are also happy to welcome our audience here in the transmitter hall today. Not least a class of students. You are very welcome, all of you. We are here today to try to start the 100 years old transmitter, SAQ, and send a message of peace to the world at 4 o'clock p.m. CEST or 2 o'clock p.m. UTC. We are all members to the Alexander Grimeton Friendship Association, a group of volunteers that are working with this unique old transmitter and keeps it up and running. My name is Anders and I will be your host today. To my right here I have our radio operator Kai. Next to him Anders, the main operator, and our assistant Lasse. The 1st December 2024, this radio station turned 100 years, but the centenary wasn't held until the 2nd July this summer, when its inauguration was held the 2nd July 1925 by the Swedish King Gustav V, together with the Swedish-American and inventor Ernst Alexanderson. On the centenary, the beautiful, newly renovated visitor center was reopened, and we had a broadcasting 2 times during the day to the whole world. And the transmitter hall was full of audience, and there are a lot of exhibitions during the day and hundreds of people visiting us. It was an unforgettable day at the World Heritage Site. And by that, before we are going to start up the transmitter, we will show you some components of the transmitter. I will begin with the Alexanderson alternator, invented by Ernst Alexanderson. Here is the high-frequency generator where the antenna current is generated. Inside here is a rotor disc in massive steel, 1.6 meter in diameter, and at its periphery 7.5 centimeters wide. On its periphery there are 488 slots cut out, filled with non-magnetic material brass. This disc rotates in a magnetic field and generates 17,200 magnetic alternation per second when it's up in speed 2,150 RPM. This magnetic alternation is picked up with 64 anchor windings and conducted up to the summing transformer in the high frequency switchgear you can see behind the alternator. The disc is driven by the main motor over here via a gearbox that is shifting up the speed almost three times. So the frequency of the motor is directly related to the frequency. So it is of great importance to keep the motor speed constant and correct. The main motor, it is a 500 horsepower asynchronous motor that is driven by 2,300 volt two-phase winded voltage. The stator is two-phase winded and the rotor is three-phase winded. We can control the speed of the motor in two ways. We can control the voltage to the stator winding by so-called transductors that are located in the transformer room. And they are connected in line with the power supply. The other way is that the windings in the stator are connected to rheostats, and by that we can control the rotor resistance continuous, and by that adjust the rotor resistance and the torque of the motor. By that, we are going down to have a look at our auxiliary machine. Now we are in the auxiliary machines area. To the right from me, we have the transformer room with where the power to the station gets into the building. There is also 4 transductors that are controlling the motor voltage. In front of me, we have a set of rectifiers that provides 500 volt DC control current to the transductors. We will use this one. This is a backup. Here we have another set of rectifiers that gives 125 and 250 volt DC for relays and for magnetizing. Down there we have centrifugal pumps for cooling. I'll tell you more about them later on. And here we have rheostats for controlling the rotor resistance in the main motor. To controlling the motor speed, it creates a lot of heat on our contactors. And here we have 2 cooling fans that provides compressed air to blow out electrical arcs and to cool the contactors. Okay. Hello. Yeah. We are now going into the relay corridor, where the Morse-coded signal enters the transmitter by this telegraph relay up there, 1.5 watt. And it is amplified in 3 steps to these 2 large relays. These relays is controlling these 4 contactors. These 3 are a part of controlling the resistance in the main rotor, and this provides maximum current to the transductors. They are working in line with the telegraph key, so they are a part of the speed control system. The compressed air is coming up here with these nozzles to cooling the contacts and blow out arcs. The other relay here is conducting the Morse signal to the magnetic amplifier in the high frequency switchgear, and there it is transforming the message to a signal out on the antenna. Okay, that was a short introduction, and now I think it's time to start up. It's time to start up. What? It's not on. Okay. To start up the transmitter. Då går du ut där först och tittar. Okej. We have done some preparations. We have controlled that all the machines are running well and that there are oil in all the bearings. Here is no ball bearings in the machines, just plain bearings, so the lubrication is of great importance. We have also connected the station to a transformer outside in the transformer room. And that's why Anders now is going out to control the switch yard, so no one is going close by. Because when we are connecting, it can be noisy and can be scary. Now Anders is back, and I will connect the transformer outside in the field. So now we are ready to start up the auxiliary machines, and I go over to this side of the control panel. I will connect a 0 voltage release, and then I connect an oil switch. And now you can hear that we have an alarm bell ringing, and that is because we have no cooling water or oil pressure in the Alexanderson alternator. We are going down to start the cooling system. We usually have two centrifugal pumps, one for running and one as a backup. Pump number 1 is under repair because of a bearing failure, so we must use pump number 2. Lasse is now opening the water supply, and is also opening a bleeding valve on top of the pump house to get rid of air pockets. When the pump is filled up with pure water and no more air is coming through the drainage pipe, he will turn off the bleeding valve, and he's going to start up the pump with a star delta switch, and the pump is running. Now is open a ball valve to open the circulation of cooling water to the rheostats, to the alternator, to the magnetic amplifier, and then back to an underground tank in a closed loop. In back in days, we used a cooling water pond outside with a cooling fountain used especially in the summertime. Now Lasse has opened has opened the valve, and we can see on the manometer on the wall that we have 2 bar. It's our operating pressure. It's equal to about 30 psi, and the water is it's closed. Okay. We are going by, and Lasse is controlling that the liquid level in the rheostats is okay. It gets hot and evaporates, so sometimes we have to add some water. Here are 3 rheostats. This is a backup. They are used to control the speed of the motor. The start rheostat is used to control the torch to the motor when we are starting up. Later on, we use it to fine-tune the motor speed. It is connected to the rotor in the main motor by slip rings in cables. Here we have the control rheostat. It is connected in parallel with the start resistor when we are using the telegraph key. And that holds the speed of the motor up when we are using the telegraph key. Yes. They both connect. They both holds a lot of water mixed with sodium carbonate to get the right conductivity. They have a circulation pump and a motor-operated gate, so we can control the level of the liquid, and by that the resistance. Okay, we are moving on. And Anders is waiting for me. He will put on some protective gloves because he is going to handle 440 volt on open contacts. He will put some wooden pieces in the start relays for the circulation pump. You can hear it flushing now, and perhaps you can see it on your screen. We have a camera down there. If we don't start this circulation pump, the liquid should start to boil when we start up the main motor. The wooden pieces will be released and fall down when we start the main motor. We are back on the control panel, and Anders will connect the alarm bell again, and we have a persistent signal because we have no oil pressure to the bearings in the alternator. Anders is going back to the emergency switch because we are handling high voltages here. And yep, I will connect a 0 voltage release and the main motor with an oil switch. There's oil in the switch to extinguish electrical arcs. Now the alternator starts to rotate. There are large masses to be handled. Only the disc weighs about 1,500 kilograms. On the ammeter here we can follow the start-up current, about 145 amps. And on the voltmeter on the other side of the panel we can see that the voltage is about something about 1,200 volts. We are now waiting for the alternator to rev up, and we are also waiting at the internal oil pump to handle the oil pressure. And then we will get an alarm, and Anders will disconnect our auxiliary oil pump. Okay. Now the internal oil pump is handling the lubrication. Now we are following the start-up current, just now 100 amps, and at about 90 amps, Anders will connect two rectifiers, and one for 500 volt DC and one for 125 and 250 volt DC. We are moving to the other side of the control panel, and Anders will connect the knife switch, and with that he's magnetizing the 500 volt DC rectifier to energize the motor with 2300 volt. You can hear the motor that is revving up, and here we can follow the speed of the motor, and it's just now about something 610, 620 RPM. We are also following the voltage to the motor. Just now it's 2300 volt. Our target voltage is about 1900 volt. When the speed of the motor reaches 700, Anders now will close the next knife switch to magnetize the alternator. Now with the two control devices, Anders has already increased the liquid level in the rheostats to get even more power to the main motor. Now we can see that the gauges are activated because now the automatic speed control system is activated. First, Anders will fine-tune the alternator to give 17,200 hertz. You can see it on the frequency counter on top of the control panel. We are waiting a little to to stabilize the frequency. Okay, are you satisfied? And satisfied? We will start up the fan. Okay, Lasse, can you go and start up the cooling fan number two? Before starting up and keying the transmitter, we must start the cooling fans. to cool the contactors in the relay corridor. We must use this compressed air, otherwise we will have damage on the contactors. Okay, Anders, the cooling fans is running. And now you can connect. Anders is connecting the high frequency generator to the transmitter via a motor operated switch. Yeah. Now he's using a test key to control that the transmitter is operating and control that everything is okay. By that, I think now Anders is going to fine-tune the transmitter when it is operated with the Morse key. And by that he is fine-tuning the control rheostat. Okay. Okay. You can switch on the key switches, and I will start up a paper tape reader here. And now you can hear a Morse signal. This paper tape reader converts the characters on the paper tape to Morse code. And just now it is sending DVV, the SAQ. DVV means hello, hello, and de is France, and SAQ is radio transmitter call sign. Just now the radio enthusiast out in the world can tune in on their receivers. This transmitter is the only one that has this call sign, SAQ. I think you are satisfied. Everything good. Okay. Okay. Then a moment. I think we leave it there idling, and I will go a short walk outside and show you the antenna. Stay inside because your headphones don't work outside. Okay. Hello? Hello? Okay. Do you hear me? Okay. In Sweden it is autumn. It is rather cold today, about 10 degrees centigrade, and it's rather cloudy, and I'm happy that there is no raining. To the right of me we have our cooling fountain running, and behind me you can see towards the cloudy sky the 6 antenna towers. Impressive constructions. The towers is 127 meter high, and the cross beams up there is 46 meter wide. The distance between the towers is 380 meters, and the length of the antenna is 2.2 kilometers. The ground net has the same length as 500 meters wide, with deep buried metal wires of a total length of about 180 kilometers. We can follow the antenna wires to the top of the towers that supports the antenna. The antenna wires is there to distribute the antenna current and the signal from the transmitter via the first antenna coil, and produce capacitance together with a ground plane, and together with the induction of the 6 antenna coils resonate the antenna to 17.2 kilohertz. From the top of each tower there is attached vertical metal radiant down to the ground plane via the antenna coil, and it is here the radio wave is produced, and it is here the radio wave leaves the antenna. Behind me here you can see the beautiful main building built in neoclassical style by the architect Carl Åkerblad. Before we are going inside, I can mention to you that the antenna was developed by Ernst Alexanderson. Now we are going inside. We are going back inside. Okay, on the right side we have our oscillating machines running. Everything looks okay, and I think yeah, we have to do some fine tuning and It looks okay. Now we are going to wait for Kai starting up and transmitting the message. Yeah, everything looks okay. We can monitor our meters and yep, we have the frequency 17,204 hertz. Yesterday we started up the transmitter to control that everything was okay, and then we had some trouble, amongst other with the antenna. So I am glad to the situation with all the that everything is okay. And yesterday we had contact with radio listeners in New Hampshire. Now it's 2 minutes left. Okay, thank you, Kai, for sending the message from us here in Grimeton radio station this UN Day. Many thanks. And I think you could see the message on the screen. By that, this message can be heard by radio listeners all over the world and be seen on YouTube and to all here in the transmitter hall. It's an important message. By that, it's time to stop the machines, and we are doing that in the opposite way of starting up procedure. So now Anders is disconnecting the nice switches for 200 volt DC. I am going to stop the alternator, and Anders is closing the rectifiers. Then Anders is decreasing the liquid level in the rheostats to the starting position, and Lasse is going down and stops the cooling fan that is not used anymore, and we can get rid of the noise. Now the alternator is slowing down, and the internal oil pump can soon not handle the lubrication. And then we will get an alarm, and Anders will start the auxiliary oil pump again. I am glad to welcome. Yep. I'm glad to welcome a well-known poet, Ingela Strandberg, from Grimeton, who wrote the telegraphed message, and now will. And you are not hearing me? Okay. Okay. The word.
Oh, great word. Oh, beautiful Earth Mother. We are listening to you and will do our best to be good children. We appeal to the mighty spirit of peace. Let freedom and human dignity rule. Everything is created to live. Humans, animals, forests, oceans, rivers. Everything is meant to resist greed and mindless, senseless destruction. May the governing, all those in authority, use their power to achieve peaceful coexistence. May every nation count human value before our divided land masses. Let us join with and use the same strong willpower to stop the bullets, silence the weapons, shorten the hunger lines to zero. May all children in the world know they are welcome. May they feel safe in safe homes. May this not just be a dream, not just a hope. May we all, in our farthest places and lives, call out the need for peace. Let this call be a global, eternal echo. Let it fly over every fence and border. May human dignity win in our lives, our hearts, and our lands. Thank you for listening.
Thank you, Ingela, for this fine and important poem to the world. Thank you very much. Okay. By that, we have finished our mission today to start up the 100-year-old transmitter and send a telegraphed message to the world. Thank you all for being with us today on your radio receivers, on YouTube, or in the transmitter hall. I will also thank the team here in Grimeton for a nice day. Once again, a big thank to Ingela Strandberg. We hope that you have enjoyed the starting up of the transmitter and that you have heard our telegraphed message well. So please send us your listeners' report, because they are of great importance for us all. And we will send you an electrical QSL. Visit our website, alexander.n.se, to get more information about how to send a listener's report, about our association, about upcoming transmissions, but most of all, how to get a member. Because we want you all as members to join us. By that, bye-bye. Welcome back. Bye-bye. Ja, det är bra.